Okay, class, welcome back. Here we are at case study 2A notes part 2, the T distribution. Okay, so case study 2A, the last thing we left off with were what were the requirements for the T distribution, and it's something that I'll talk about a lot. They're here in red and purple and underlined in red and purple in the theorem. Okay, we must use S to estimate sigma, and the histogram has to be roughly bell-shaped. So it either has to the problem either has to tell you it's coming from a normal, near normal distribution, or you have to see a histogram of something that looks fairly normal. All right, so first we have properties of T curves. The T distribution and the normal distribution are both continuous distributions. There are many similarities between the T curves and the standard normal curve. Some of those similarities are centered and symmetric about 0. So that means when we go to draw T curves, both T curves and normal distributions are centered and symmetric at 0. They are both bell-shaped. They extend indefinitely in both directions and have a total area under the curve equal to 1. Okay, now those are the similarities. Some things that T curves have specific to them is that as n gets larger and larger, the T curve gets closer and closer to the standard normal curve. Every T curve has a certain number of degrees of freedom. Degrees of freedom is equal to n minus 1. Okay, that's going to be the easiest formula, the shortest, I should say, and easiest formula. You'll have to know all semester and make sure you know that formula. It's what we're going to need whenever we go to using the chart. All right, so what I have here is a picture of some T curves overlaid with a normal curve. And this little circle is what I have blown up here on the left-hand side. So as you can see, as our degrees of freedom, thus the sample size, gets a little bigger, this curve is coming in closer and closer to this Z curve that we have outlined here on the bottom, okay? Those are going to be some good facts to make sure you know about T curves. The T distribution is found on the following pages in the textbook and those following pages in your case study manual. All right, so we're going to go through a couple examples here. Suppose T is a random variable with a student T distribution with 5 degrees of freedom. Okay, something we have to know how to do is how to write our distributions. Well, how do we write this? T follows a student's T distribution with 5 degrees of freedom, okay? I kind of want to make a note here about a couple things. So this T is referring to the T random variable. All right, new color. T5 is referring to the student's T distribution with 5 degrees of freedom. So it might feel like the letter T is floating around a lot, but we're going to have our T distribution and our T test statistic. All right, find T naught such that the probability that T is bigger than T naught is 0.025. Okay, and so what I have is I left just enough space to draw a picture of this. All right, so we have a symmetric bell-shaped curve that is centered and symmetric at 0, okay? And we're somewhere down here at a positive T naught value, and we have 0.025 in the area above it, okay? And this would also be the area that you would shade. All right, so go ahead and make sure at this time that you have your T chart handy, and I'm going to show you how to use it. All right, so one of the first things to note is that your T table is dictated by degrees of freedom, okay? We always have to start with the degrees of freedom first. So this last problem told us we had a degrees of freedom of 5. So I'm going to use the bottom of my computer as like my sheet of paper to kind of cut off what we're talking about. So here we are at degrees of freedom 5, and notice this top row up here, this is what's going to be our area or probability. All right, so we were looking at, we can switch back over, a t distribution with 5 degrees of freedom, and 0.025 area is above t. Okay, another couple things to note is that we have upper tail probabilities here. So things that give us, that have greater than signs in them, which our problem does have. Greater than t naught. All right, so I come to degrees of freedom line 5, and I want to come down 0.025, and that puts us right here at 2.5706. So my answer to T naught in this question is going to be 2.5706. So this was an example where I gave you a probability and you found a T value. We're going to go in both directions. All right, let's look at this next number. Find the 90th percentile. All right, so if you kind of remember what the 90th percentile means, it means that there's 90% of the data below some value. Okay, so I'm up here, some t value, need to find it. Okay, and 90% of my data falls below t. So if 90% is below t, how much is above t? 0.10. And that 0.10 comes from 1 minus 0.9. Okay, so now we still have 5 degrees of freedom, and now we're looking at 10% being above it. All right, so we're still here at 5, and now I want to come to 10. So the t value is 1.4759. Oop, it looks like I have a slight typo. 1.4759. Okay, so those are two examples where if we start at the top with a probability and go down. Okay, now what we're going to look at next is if we are going the opposite way. If we have a t value and we want to find a probability associated with it. All right, so suppose t follows a student's t distribution with 19 degrees of freedom. All right, so there's a couple things I want to note here is that that's how you write it and that's how you say it. Okay, so that's an example of writing the distribution and how you would say the distribution. Okay, so we want the probability that t is greater than or equal to 2.5395. All right, and I'm going to write my answer right there when I get it. So again, starts with drawing your picture. Okay, our t curves are always centered and symmetric at 0. So if I'm at 2.53, that means I'm somewhere up here. 2.5395. And this is telling me I want the area above 2.5395. All right, so let's keep these numbers in mind when we go to the next page. We need the degrees of freedom, and we need our t value. All right, so we're dictated by degrees of freedom, so that's what we always want to go to first. So there I am, at the very bottom, you can see I'm at 19 degrees of freedom. Okay, now in this problem, I am wanting the probability. I'm wanting the area, which, come on. I believe I erased it, but up here is where you will find the area. All right, so if I'm here at 19 degrees of freedom and I have a t-value, okay, the t-values are in the center of your chart. So what I'm going to be doing is starting at line 19, I'm going to scan from left to right, and I'm looking for 2.5395. And I'm in luck, I find it right there, 2.5395, so I go up, and 0.01 is the area that's associated with being above 2.5395. 0.01 is going to be my answer there. All right, let's do another problem like that, okay? Same thing, we still have T, 19 degrees of freedom. Okay. When I get my answer, I'm gonna put it right there. Draw my picture. Zero's in the center. Now I'm looking at being less than negative 1.3277. Okay, now if we look at our t-table again, everything we've done so far has been dealing with the greater than probability. Well, now we have a problem where it's giving us a less than probability. So what we have to do when we're considering a less than probability is use our idea of symmetry. Okay, so I have this little area shaded down here. This is what I want. So the probability of being less than negative 1.3227 is going to be exactly the same as this area that I now have in pink. Being greater than positive 1.3277. Okay, so when I go to my chart, I'm going to utilize the fact that my chart is an upper tailed and that my t-charts have symmetry. So instead of looking for less than negative, I'm going to go to my chart and look for what's greater than positive 1.3277, knowing that it's going to be the same. So here I am at 19 degrees of freedom, okay, and then I'm going to start here and I'm going to go across, and here I see 1.3277. All right, so that's going to mean I'm going to go up to the top, and 0.1 is the probability I'm looking for. Okay, so this area is 0.10, this area is 0.10 because of symmetry, again, making our final answer be 0.10 or 10%. Okay, let's just keep on moving on. So suppose we have a t distribution of t27. Find the following probabilities. Okay, so with these second two examples, number two, the numbers that we found fell perfectly on the chart. That's not always going to be the case, especially when we're calculating test statistics and the data we get is just raw data. It's not always going to fall perfectly on the chart. So we're going to have to get an estimate as close as we can. Okay, so we want to find the probability that t is greater than 1.87. So again, best place to start with is a picture. I'm over here at 1.87, and I'm going to show you this area above 1.87. Okay, so similarly to the problem above, I'm going to start with degrees of freedom 27, and then I'm going to scan looking for the number 1.87. All right, let's start fresh here. Okay, degrees of freedom 27. All right, so degrees of freedom is 27, and I'm looking for the number 1.87. I'm scanning 1.81. Okay, so 1.87, if you notice I made a little mark, is right there. It's between 1.81 and 1.96. So I'm going to go up. Whoop. So that means my probability, okay, my t-value falls right between these two numbers, which means my probability is going to fall right between those two numbers, 0.03 and 0.04. Okay, now that's as close as we can get it without using utilities like Excel. So that means that the probability that t is greater than 1.87 is going to be bigger than 0.3 and smaller than 0.04. Okay, that's as close as we can get it. Again, using utilities like Excel or some, graphing calculators, you can get exact probabilities. And if you get an exact probability for this, it will be a number that lies somewhere between 0.03 and 0.04. Okay, so I just want to talk y'all through that just one more time. So I'm starting with degrees of freedom 27, and I'm looking for the number 1.87. Okay, so I come here to degrees of freedom 27. I'm coming across from left to right, scanning for 1.87, 1.87. Oops, it's going to be right in between here. So then I take my cursor up, and so that means my probability is right between 0.03, 0.04. So you want to make sure that these signs always make sense, because 0.03 is smaller than 0.04. So writing the signs this way, wouldn't make sense with the numbers. So after you've went ahead and written out your final answer, which should look something like this every time, just make sure that your two end answers make sense from left to right. Okay, let's do another one. The probability that t is less than or equal to negative 1.197. So I'm down here at negative 1.197, and I want the area that's less than negative 1.197. So our t-table doesn't give us less than values. It only gives us greater than values. So again, I'm going to use the idea of symmetry to help us. And when I go to the chart, I know I'm going to look up positive 1.197, and that this area above it in pink is going to match also my shaded area down here in blue pink. Okay, so my degrees of freedom is still 27, and now I'm looking for positive 1.197. So 27, 1.19, looks like it falls right between there. And if I go up, my probability is right between there. So those are the two probabilities that I am now concerned with. So 0.1 and 0.15. So again, if we were to completely cover up what's here in the center, you want to make sure your signs make sense. Is 0.1 smaller than 0.15? Yes, it is. Okay. So our final answer there is 0.1 is less than the probability that t is less than or equal to negative 1.197, which is less than 0.15. Okay, so that's got some practice with the t-table. Okay, one more thing we can use the t-table for is to find our table value for confidence intervals. So suppose we have a random sample of size 18 that is drawn from an assumed normal population and sigma is unknown. What are the degrees of freedom? Well, it's a good time to note that, anyone remember what the formula for degrees of freedom is? N minus 1. So if our sample size is 18, then that means our degrees of freedom is 17. Okay, find the t-value that you would use to build a 95% confidence interval for mu. So every time you build a confidence interval for mu, you will have to go get a new t-value. Okay, the t-table differs from the z-table in that every single degrees of freedom that you see down here along the side will give you a slightly different distribution. Those are all slightly, ever so slightly different distributions. So every time we calculate a confidence interval for mu, when we're talking about t, we have to go get a fresh t value. All right, so I'm gonna start with my picture. Okay, and I'm building a 95% confidence interval. So 0.95 goes in the center. Okay, y'all remember how we find what's left over? We subtract from 1 and we divide by 2, and that's going to give us 0.025. Now that's the value that goes in each tail. Okay, so we have some negative t value, we've got some positive t value, and we want to determine what that value is. So since our table gives us upper tail values, I'm going to get the positive t utilizing this upper tail of 0.025. So degrees of freedom 17, 0.025, go to my chart. I want to go to 17 degrees of freedom, okay? And I was given an area this time. I was given an area, so we're going to start here at the top. And I got to 0.025. All right, so then go down. 2.1098 is going to be our answer. Okay, so this is the table value you would use in your confidence interval calculation. Okay, let's do one more like that. So find the t-value you would use to build a 90% confidence interval for mu. Okay, so again, I want to start off with drawing my picture. %. So we determine what goes in each tail. It's going to be 0.05, 0.05. Okay, and now we're going to do the same thing. We still have 17 degrees of freedom. Okay, and now we're going to go past, since we're starting with an area, we're going to go past 0.025, go to 0.05, and then go down to 1.7396. Making 1.7396 the number that we would use in the confidence interval formula for mu. Okay, that's going to be the end of video 2. Now, I know this is a new distribution that you're learning. Go ahead, check out the T practice that I posted on D2L. It gives you about 12 more examples similar to these past, 6 that we have gone through. All right, see y'all next time.